Okay, so let's look at a couple examples for identities. Identities can be very challenging, but I know that you'll find that the more that you work with them, the easier that you're going to find that it is to understand, I guess, these mini little puzzles. Um, what I have found for most students is that it's easier if you look at things that relate it back to algebra, because a lot of these is that's what you're looking for. I'll come back up to these in a second. But the thing with the identities, these are 5 rules that are going to get you through. First of all, remember your algebra skills. Remember finding least common denominators, multiplying by conjugates, being able to factor. And those tips are very useful. Remember that we can't divide by trig functions. These are not equations. You should only work from one side when you're working these. I can't work from both sides because I can't divide both sides by sine theta. They are not equations. They're little proofs. You're trying to show how one side equals the other. You want to show all your work. This test is going to be taken on campus in paper and pencil. So being able to show all your work is going to be key. And the easiest thing that you can do is always work from the most complicated side, because it's easier to break that down than it is the side that is already simplified. So here's some examples of using your algebra skills. It's nice if you can write these in terms of sine and cosine as much as possible, because they tend to have the best relationship. So I want to look at seeing tangent times cosecant. Well, tangent is sine over cosine. Cosecant is 1 over sine. So when I do this and I cancel, then I get 1 over cosine. For the second one, notice that you're multiplying top and bottom by the conjugate. When you do these, that's going to be a common thing. I have sine theta over 1 minus cosine theta. Well, the conjugate of 1 minus cosine theta is 1 plus cosine theta. So you need to multiply top and bottom by the conjugate. And what that does is it creates this 1 minus cosine squared, which is an identity. And you'll find that that works a lot. In the third one, it's all about knowing your common denominator. So here my common denominator is sine theta times cosine theta. So I multiply the top one by cosine theta, and the second one I multiplied by sine theta. Distributed the cosine here, distributed the sine here. Use the identity that cosine squared theta plus sine squared theta is equal to 1. And notice that these two canceled each other out. And then it's just 1 over my denominator. Sometimes you're going to do things like multiply and simplify. So here I have 2 binomials. So we FOIL to get cosine squared plus 2 sine theta cosine theta plus sine squared. What that does is it gives me the sine squared plus cosine squared. That's 1. And then I still have my 2 sine theta cosine theta. But notice that the 1 minus 1 cancels. We distribute the negative inside. And then this simplifies down to negative 2. So you want to look at little tricks like that with the algebra. Again, these 5 tips are going to help you. I would say the best one is being able to only work from one side. If you work from both sides and you try to get them to the point where they're equal, you're going to find that you struggle with this more than you need to. And as you move through more math, then that technique of being able to work from one side for proofs is really going to be helpful. So in this case, notice that I have tangent squared theta cosine squared theta plus cotangent squared theta sine squared theta equals 1. So I choose to work from the most complicated side. In this case, the left side, obviously, because it has more stuff to work with. The easiest thing you can do here is turn everything into terms of sine and cosine. Tangent squared theta is sine squared theta over cosine squared theta. Cotangent squared theta is cosine squared theta over sine squared theta. What this does, cancellation in fractions. Sine squared theta plus cosine squared theta equals 1, and now I've shown that both sides are the same. When you take a test, you want to be able to show all these steps. Here, I want to show that 3 sine squared theta plus 4 cosine squared theta equals 3 plus cosine squared theta. The more complicated side is the left side. Notice I don't even touch the right side. It stays the same throughout everything, and that's where I'm wanting to head toward. So what I do is, it's complicated because it has 2 different trig functions. So you have to ask yourself, where do I want to end up? I want to end up looking like the right side that only has cosines. So I need to take this sine squared theta, using my Pythagorean identity, and rewrite it in terms of cosine. Then I can distribute the 3, and I keep the 4. So then I end up with negative 3 cosine squared theta plus 4 cosine squared theta. Combining like terms gives you 1, and then you have the 3. So I took the left side and made it look like the right side. If you see a tutor, a lot of times they'll tell you to work from both sides to try and get them to look the same. I'm telling you right now, you're going to struggle. It's just so much easier to focus only on one side. Plus, like I said, further on in math, when you have to do proofs, you don't get that option. This is one where you're going to see this a lot. Notice that if I do conjugates, I could do that, but there's a trick to this, because notice that cosecant and sine are reciprocal functions. So they're going to do things like they're going to give you cotangent on one side and tangent on the other. Cosine on one side, secant on the other. So pick one side or the other. In this case, I picked the right side. And I'm going to multiply every term in the numerator times cosecant v. And I'm going to multiply every term in the denominator by cosecant v. So 1 times cosecant v. Negative sine v times cosecant v. In the denominator, 1 times cosecant v. And then sine v times cosecant v. Well, if you take a reciprocal times itself, right? A times 1 over a is equal to 1. So then I end up with what I had on the left side. Again, I'm only working from one side of the proof. It's not an equation. I can't cross multiply. I can't divide across the equal sign. These are not equations. So let's look at one more here where we want to take 1 minus cosine theta over 1 plus cosine theta and make it equal to this binomial squared. When you have a trig function 1 minus or 1 plus and it's to the first power, think conjugate. Okay, I'm going to multiply top and bottom by the conjugate of the denominator, because what that does is that creates this 1 minus cosine squared theta, which is a Pythagorean identity rewritten into sine squared theta. And then I have a trinomial divided by a monomial, so we can break it apart. 1 minus sine squared theta, dividing each term by sine squared theta. And then here in the middle is where I've broke out this middle part. So 1 over sine squared theta is cosecant squared theta. Here I'd have 2. Cosine theta over sine theta is cotangent theta. And 1 over sine theta is cosecant theta. And cosine squared theta over sine squared theta is cotangent squared theta, which when factored is cosecant theta minus cotangent theta squared. So notice that I took the middle term, it was divided by a sine squared theta, and I broke it up into 2. So I hope that these brief examples help you solve the identities. And as always, please reach out to me if you have any questions. We can always go over these through Skype or via email or on the phone.